If it's not an easy practice, they may.
Hello, everyone. This is Mehmet Aktas. I am an assistant professor at Institute for Insight at Robinson College of Business at Georgia State University. Today, in my time, I'm going to try to briefly mention some nice applications of network science in business intelligence. Here is my outline. I will first talk about what is network science. And in the second part, I will give some. Of course, there are many applications of network science for business intelligence, but I will briefly mention some of them quickly, actually. All right, so first of all, can we imagine a world where people have no friends or where roads never intersect? It's impossible, right? So relations are actually inevitable in our real world. We are all related to each other in one way or another. Animals are related to each other. Not only actually people and animal, all other actually roads are related to each other. Flyers, airplanes are again related to each other. So we can define relation everywhere in our life. And that's why our life is completely defined by networks. And behind every complex network, there is every complex system, there is always a complex network that we can build. For example, if you think about brain, right, we have neurons and there are interactions between neurons, so we can come up with a complex network. Or if you look at the interaction between gene and proteins, again, we can come up with a complex network. The most easy example actually is social network, right? If you look at the social media, it makes up again a complex network. Or if you look at the infrastructure of telecommunications and all the other different actual settings, we can come up with the network structure. So networks are basically everywhere nowadays in our life. But wait a second. So what is network, first of all, in terms of data analysis? So networks, as most of us know actually, these are actually structured data and they are representing relationship between objects. So, and we represent objects with vertices and relations with edges. So what are some examples? Again, social networks are a nice example for that. Each user in a social network, for example, in a Facebook network, are vertices. And whenever there is a relation, friendship relation between them, we can add an edge. Or collaboration network is also a social network. What else? Communication network, right? Email networks are also very common. So people are again use vertices, and whenever they email to each other, we can put an edge between them. Biological networks is also very, very common nowadays. For example, protein-protein interaction networks or drug-drug interaction network. Proteins are vertices, and whenever two proteins interact same part of the body or same maybe enzyme, we can put an edge between them. Or financial networks, again in business world, are very common. For example, we can say companies are vertices. Whenever two companies are buying the same stock, we can put an edge between them. So to short, wherever we can define a relation, we can always define a network out of it. And for example, real estate network, countries can be network vertices, and wherever we can define a relation between those real estate world of each between country, we can add edge between them. Okay, for example, in the human brain, we have about 90 billion neurons, which makes 90 billion vertices in our human brain, in our actually brain network, which is a huge network. Or for example, Twitter, right? We have about, maybe this number is now bigger than what I have here, about 400,000 users, right? And as you see, if you look at this network, it is actually, again, a huge network. And as I said, yeah, we have social networks, economic networks, biomedical networks, and information networks, internet networks, networks of neurons, and all other different data are actually nowadays represented by networks. So networks are very common and very emerging field. Interdisciplinary, as I said, you can define network in many different settings, in social science, in finance, in business, in biology, in chemistry. That's why it is very interdisciplinary. And a lot of applications, for example, in social media, we can find communities with network mining tools. Or in bioinformatics, we can find new interaction between proteins, again, with network tools. In finance, it's very common. We can model financial contagion system risk, or I don't know, yeah, we can look at the stock correlation network, for example, as another nice example. And in healthcare business, drug-drug interaction prediction is very important. So we can again come up with a network model for drug-drug interaction, and we can use that model for prediction. Okay. All right. Let me also briefly mention what are some basic graph, what are some graph types. Since relations can be right in many different ways. It can be pairwise relation. It can be a group relation. It can be a directed relation. It can be a strong relation. Since relations can be different, we can also come up with different graph types for that. Of course, the basic one is just with a vertex and edges, pairwise relations. Or we can improve that using weight on edges. And weights are actually showing a strongness of the relation between vertices. Or even if there is a direction in the relation, for example, maybe A is a friend with B, but B is not following A, then we can put a direction also on our edges. It makes up directed networks. Or actually, yeah, beside the network structure, if we have attributes for vertices or attributes for edges, it can make up a attributed graph. And we can also incorporate these attributes whatever we want to do. Or we can use bipartite graph where we have two different actually vertices, and we cannot have edge between the same type of vertices. Hypergraphs are also very common. In hypergraphs, we are modeling not only pairwise relation, but also a higher order relation. So the relation can happen not only within two vertices, but it can be happening in a group of vertices. In those cases, we use hypergraphs. Heterogeneous graph, whenever we have different types of vertices and different types of edges, we can come up with a heterogeneous graph. I am going to give some examples in the coming slides. Multi-layer graphs, again, maybe our graph has different layers. Maybe one layer is for friendship, another layer is for, I don't know, authorship. So that's why we can also show these different layers of information also inside graphs. Dynamic graphs is also very common. So wherever we can update our graph during the time. Maybe we can add an edge, maybe delete a vertex. All possible updates are actually okay in the dynamic graph setting. And knowledge graph, as we all know, we can also come up with a knowledge graph where vertices will be some concepts. And wherever there is a citation information between concepts, we can put an edge between them. And of course, these are not all the graph types. There are also other types of graphs, but these are the basic maybe graph types I can. And some example, as I promised, for a bipartite graph, for example, we can say owners are vertices and stocks are vertices. And whenever one people are actually buying one stock, you can put an edge between them. This is a nice example for bipartite graph. Social network, for example, Twitter network is actually a good example for heterogeneous network because we can come up users as vertices, but at the same time, we can come up tweets as vertices, right? And whenever, for example, a user like a tweet, we can add a like edge, or whenever a user posts a tweet, we can add a post edge. So as you see, we have different types of edges and different type of vertices. So this nice model is actually representing that complex relation within the Twitter networks. Again, biological networks are a good example for heterogeneous network. Again, we have different types of vertices. For example, it can be a protein vertex, DNA vertex, drug vertex, disease vertex. And we can define many different relations between them, right? For example, we can define association relation between drug and disease. But at the same time, disease is also linked with a virus. So as you see, there are different actually types of relations and different types of vertices. So we can model that. Co-authorship network is an example of a hypergraph. As I said, hypergraphs are modeling higher order interactions. So for example, if we have 3 people co-authoring a paper, we can put a hyper edge between them. Or multi-layer network, as I said you, for example, we can come up with a work network for the same set of vertices. Maybe those people are going lunch in different ways. Maybe they are friends on Facebook in different ways. As you see, we have different layers of relation, and we can also show that with a multi-layer network. Similar for actually co-authorship network. Authors can have vertices, edges between them, but paper also has some citation relation, and topics can be also related to each other, and words as well. So as you see, yeah, we can also come up with different types of networks. Okay, this is just a brief introduction into this nice topic. Let me now talk about, in my remaining time, let me talk about some nice applications of graph mining or network mining for business intelligence. Of course, these are not all the applications, but these are the one maybe mostly and commonly used. Let me start with link prediction. So link prediction is the problem of predicting whether two nodes are connected or not. And maybe they are not connected, but they are likely to be connected. So how can we predict who will be connected maybe in the near future or not? This problem is called link prediction. And of course, the link prediction is very useful in many settings. For example, in social network, we can use for friend recommendation, right? Maybe this user and that user are not friends, but we can predict by using link prediction. Or in in shopping websites, for example, in Amazon or eBay, product recommendation can be based on, again, link prediction. Or in a finance network, stock recommendation can be, again, with the link prediction. And of course, these are just a few examples. What about node classification? And in node classification, this time we have labels for nodes. And for example, what can be labels of node? For example, in social network, labels can be gender, or labels can be occupation, right? And whenever we have a new user in the social network, what will be the label of that new user? Can we predict that? So this is called node classification problem. And of course, how can we use node classification? For example, if we have a drug-drug interaction network, and we would like to understand whether a drug is effective to a specific type of cancer or not, this could be the label. We can use that, right? Or if you want to, predict stock labels, maybe we have a bank stock or we have a real estate stock. How can we predict those stock labels? Again, it is node classification, and so on and so forth. Yeah. For example, if it's a music network or a text network, can we predict the type of the text or maybe type of the music? Again, this is with node classification. Another important area, I believe, implication area, is recommendation systems using graphs. For example, again, we can use heterogeneous graph for recommendation system. And in this example, yeah, how can we recommend a song actually to a user? And we know his or her previous information, right? Maybe she listened these songers, this type of music. Maybe we can also define different actually type of relation between all these different vertices. And after modeling all these actually complex structures for each user, we can come up with some recommendation based on, again, link prediction. So recommendation systems are also using graphs. What else? Yeah, community detection and community search. This is also a very well-studied problem. This is actually a kind of old problem. How can we detect communities in social networks or in general in networks? And what is community? First of all, communities are closely related, cohesively knitted subgraphs. So there should be many links within a community and few links between communities. So how can we come up with this idea of community? And also there is another problem, community search. It is similar to community detection, but slightly different. In community detection, we just look at all possible communities. But in the community search, we just give a query vertex, someone maybe, or maybe a group of people, and we are interested in finding the group of community of this given vertex only. Yeah, this is actually community search problem. And again, how can we use this community search problem and community detection problem in social networks? Again, friend recommendation, right? Maybe after you find a community of a query vertex, if someone is not directly connected with that query vertex, we can recommend that, right, as a friend. Yeah, usually the same idea. We can use, we can recommend stock to users, right? Or music again for the users as well. So yeah, community structure is also quite important. Another recent, actually, the graph neural network is very recent. So graph neural networks is also using the idea of neural networks, but in this time, message passing is happening between vertices. So we basically incorporate graph structure into neural networks. So as you see in this example, if we have a target node, it just takes a message from his neighbors, but it just keeps passing messages between neighbors. And at the end, we can again use this graph neural network for node classification problem if we want to understand whether a given node has a specific label or not. Or there is also a problem called graph classification. So sometimes we can end up with too many graphs. For example, let's say we have a graph for each music, and let's say we have 1,000 music. So how can we predict the type of music? So how can we predict actually, right, labels of the graphs? So graph neural network is also recently has been used for that reason. Last but not least, of course, we can also use frequent pattern mining method in social network or in networks in general. So in networks, there can be some pattern, some relationship pattern that could be happening more often than others. So how can we detect those substructures? For example, this could be important for anomaly detection in networks. There could be some maybe a bad happened, a group of people together, and now how can we detect this? And maybe they are happening together very often. How can we detect this frequent substructure? This is another problem. And again, it can be useful, as I said, in anomaly detection problem, in bot detection problem, and all other different problems. Okay. All right. I know this was a very very quick presentation. I wanted to give some taste, at least some taste of how we can incorporate network science into business intelligence. If you have any questions, if you have any comments, you can email me. This is my website. And I also would like to advertise our master's program. We have a very well structured data science and analytics master's program at our college. And this is actually this QR code is for that. If you want to get more information, you can just go there and click on this QR code. But at the same time, if you go to virtual booth, we have also a table in that virtual area for our master's program. If you have any questions about our master's program, you can also go there. Okay, thanks so much for your attention. I will keep you. I hope we will keep connecting in different ways. Okay, thanks so much.